By the way, the crater in Arizona, called Meteor Crater for obvious reasons, that can sink a 60-story building. And that's not even a mile across. And now we're talking about a crater more than 100 miles across that took out the dinosaurs.
That famous one in Arizona can sink a 60-story building?
If you put dirt up to the rim of that crater, you can bury a 60-story building.
Wasn't that an instance where this is your whole calculation about explosions and about the amount of energy, that they were looking for the raw materials that caused that crater?
Correct.
They thought that they could mine it.
Correct. They first thought it was volcanic, and the geologists thought it was volcanic again. But one geologist, in particular, Eugene Shoemaker, who was in line to be on one of the lunar missions, and then he had like a heart murmur, and then they sent Jack Schmitt in his stead, who's also a geologist turned U.S. Senator from Arizona? Where was he senator from? I forgot. But can you look at Jack Schmitt, where he was senator from? Forgive me for forgetting, because I'm friends with him, so I should have known that.
NASA.
Jack Schmitt, SCHMITT. There's no D in it.
Mexico?
Yeah, so I was right. So it's in New Mexico. Oh, I said Arizona, so New Mexico. So he, but anyhow, he's saying, no, this is an impact crater. And well, if it's an impact crater, where is the meteorite? It must be buried down here. And so there were miners. There were iron miners who bought the land so they can get this huge meteor that they were sure was just sitting down there that they could mine for its natural resource. They could not find the meteor. That's because it hit at high speed velocity. It was a high velocity impact, which means its collision energy was greater than the binding energy even of the iron atoms itself.